Right, Stats Basics Part 3. So we just got done talking about random chance and how that affects our null and our alternative hypotheses. So the point we're kind of at here is, okay, I've got all these numbers, I've got my predictions or my hypotheses. Now how do I get to the point where I know what is what? Or how do my data points tell me, yes, this is a significant difference, or no, it's not? So that introduces the idea of these values that we use. So you'll hear t-tests, you'll hear f-tests, you'll hear about an ANOVA test, the SEM, all of these different things that we use as tools in determining precision or accuracy or reliability between one instrument and another. So I'm going to simplify, we're going to stick with the t-test because the concept applies to the f-test and a lot of the other tests that we'll do as well. So when we run a t-test, or we run statistics with a t-test, and typically a t-test is to compare two averages. So I have one instrument that ran a bunch of tests. Let's say I'm running potassium on one instrument. I ran it 100 times on one instrument, and then I ran those same samples 100 times on another instrument. Now what I need to see is there a difference between these two? So a t-test would be very helpful with that. So when I run this test in Excel, which you're going to learn how to do in this course, you're going to end up with a t-value, and you're going to end up with a critical t. And sometimes your t-value is referred to as the t-stat in Excel. So this is the key to all of this. So my t-value might be like 2.011, and my critical t might be 1.345. Basically what you're doing is you're comparing these two numbers, and the comparison between the two is what's going to give you your conclusion. So before we talk about that comparison, your t-value is statistically derived from your sets of data, or your numbers that you've got. It takes all those numbers into account. It looks at the differences between those numbers, or essentially how far those numbers vary from the mean, and it combines all of that information into one number. Your critical t is basically taking the number of data points that you have and combining that with your alpha level. Or it's basically saying, hey, if I ran 100 tests and I'm going to allow a 5% alpha level, what is that number that I should be getting? Or what's the, basically what your critical t is what is the highest t value that I can get before I know that something other than random chance is causing my differences. So with that being said, here's the key. If my t value is greater than my critical t, I must reject the null hypothesis. If you can get that pounded into your brain as best as it'll possibly go, do it. Because I will tell you, most of the questions and the test points and everything else that are missed is because students can't remember this point. If my t-value is greater than my critical t-value, I reject the null hypothesis. What this means, if this t-value is greater than my critical t, something is going on that's changing my values. Or the differences that I see between the two sets of values is something other than random chance. The null hypothesis says there's no significant difference, or the difference that I see between two sets of data points is just random chance. Does that make sense? So if my t-value is huge, or gets really big, at least bigger than this critical t, that's telling me, hey, the differences that you're seeing isn't just from random chance, something's going on. You can say it the other way. You could say if your t-value is less than your critical t, then you accept the null. I've heard this also said, fail to reject the null, which I think is just making things more complicated. So if my t-value is less than my critical t, I'm going to accept this null hypothesis, which says, hey, the differences that we see between these two sets of data is just random weirdness. Does that make sense? So if I'm looking at those potassium values, one instrument runs it 100 times, the other instrument runs it another 100 times, there's going to be some differences. We know that. But if they're differences that are happening less than 5% of the time, we're going to attribute that to random chance, and we're going to accept this null and say there's not really a statistically significant difference. That's what we're getting at with these t-values and our critical t's.